the normal probability applet. And it says, use the normal probability applet to find the combined area under the standard normal curve that is to the right of the z, which is 1.358, and to the left of z, negative 1.358. Round your answer to 3 decimal places. Example, blah. So
913.
I get 0.175.
Oh, oops. I did the middle and then not to the right and to the left. Yep.
So 0.175.
Hang on. I messed mine up.
I'll read number 4 while you're looking at that. So, which of the following would have will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, the distribution of the sample means. This cannot be determined from the information given.
I would think the distribution of the individual observation. Wait, no.
I think it's of the sample means. The distribution of sample means.
Yeah.
Wait, what did you have for 3? 1.7?
1.75.
Okay. Which of the following rules implies that the spread of the bar X decreases as the sample size increases? Normal distribution, the 68, 95, 97 rule, the central limit theorem, the law of large numbers.
I think it's the central limit theorem.
Yep, that's what I put.
All right. I'm with you on that.
Did you guys do the homework already and take the quiz for this lesson for 7?
I haven't taken the quiz for 7 yet, no.
There's the math.
I'm in the same boat.
A lot more math in this one.
Yeah.
Yeah.
You got 6 there, Kayla?
Yeah, so Diane earned a score, well, I guess we could read the beginning. Scores on the quantitative portion of the GRE are approximately normally distributed with the mean U of 150.8 and standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding with Diane's score? So, hold up.
Got 1.045.
So this equation keeps confusing me. So so basically to do this, you do 160 minus 150.8 divided by the sample, the standard deviation divided by square root of sample size, right?
Well, because there's no sample size, we're just taking the lone sample in this one. You don't do it divided by the square root of the sample size.
Okay.
You just do the 160 minus the 150.8 divided by 8.8.
Oh, okay.
We will do that in the next couple of questions, though, for sure. Is that what you guys got, 1.045?
Yes.
Yep.
Number 7, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So we just go into the applet and put 1.045 and then shade just the right. And we get 0.148.
A random sample of 5 students was selected for the GRE. Their scores are 160, 175, 163, 149, and 153. What is the Z-score corresponding to the sample mean of the students' scores?
So on this one, I was looking at this one a minute ago. I'm guessing we average those scores, right?
Mhm.
Yeah.
And then we take, so those equal 800 divided by 5 equals 160. So then we're right back to the 160 minus the 150.8. But then that's where we divide it by the 8.8 divided by the square root of 5, right?
Yes.
So I get 2.338.
Yep, that's what I got.
2338.
Mm-hmm.
Yeah, that's right.
2.338.
Yep.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
This one I have no idea.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Oh, so maybe we go. So maybe we just go back to, maybe it's the same as the first one. Do we just go back to 160? Our mean was 160, right?
Uh-huh.
Minus 150.8. Oh, so do we just take that 2.338 and plug it in? Because we go back to, let's see, what is the probability of 5? What z-score do we use? Are we using 2 different z-scores from the 2 different means and then combining them, or are we using just the 2.338 or just the 1.045? Mean score.
No, so it's only concerning the previous 5. So we're not going to go back to the 1.045.
Take the right skew of the 2.338 and it's just 0.0097. I think that's a really confusing way of what it's asking. See, but it doesn't say the 5 randomly selected students above.
Right.
So maybe we just have
No,
to.
it says, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem, which was the one that had the five students.
Oh. Then I think that's it, 0.0097.
Yeah.
What do you think, Kayla?
I think that makes sense. Yeah, 0.0097.
I think we'll see in a minute, huh?
All right. Suppose the mean GPA of BYU-I students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students who was selected? I'm going to say approximately normal because of the student size, or the sample size.
Yeah,
Agreed.
it's a large sample size.
All right, 11. What is the mean of the distribution of the sample means for all possible samples of size 81? Sorry, my dog's going crazy. Of 81 that could be drawn from the parent population. So we just go, in this case, we go 3.5 divided by 0.7 divided by the square root of 81, right?
Yes. Wait. 3.5.
Oh, the mean.
Yeah.
It's just 3.5.
Yeah.
Sorry.
Because the mean of all mean
What is,
of all possible means of 81 is 3.5.
yeah,
I think question 12 is asking what I was thinking.
Yeah,
So
standard
what is this?
deviation of the sample size.
All possible to 81. So that's the one where we're going to go. Oh, we just take the normal standard deviation. We just go to 0.7 and
Yep.
divide it by the square root of 81, right?
Yeah, square root of 81.
I got 0.078.
Perfect. This one is this to 3? Oh, yeah, okay, to 3. Number 13, what is the probability of the mean GPA for 81 randomly selected students that will be less than 3.3? So we go, let's see, 3.3 minus 3.5
Yep.
is 0.2. And then because we're using the same 81, we can go
Divided by,
0.078, right?
yeah.
Yeah.
And that was -2 divided by 0.078. Ooh, is that right? -25?
Wait, no.
Skip a step.
Negative 0.2.
Oh,
0.2 divided by
I got
0.078.
-0.2 divided by,
The
0.078.
yeah, the 0.078. So negative 2.564.
-2.564, and then we're just looking at the left shade on that, right?
Yeah, man.
0.0052. 0.005,
0.005.
right?
Negative 2.
Yeah, that's what I got.
Yep. .0050.
Okay, and then for the greater one, it's going to be 0.995.
Oh, is that all 14 is? Just the opposite of that?
Yeah, it's just we'll have greater than 3.
0.995.
Yep.
Yep.
Okay. So last one, 15, right? United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers was recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, that was observed in this sample. Wow. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the means as in the pop. Ours.
Right. So that would be the two outer edges.
So what the heck's it asking? Find the probability that a random sample of passengers will have a weight that is more or less than.
So we need to find the z-score and then plug that into the normal probability app and then select the two outside.
Okay, so we go let's see.
So 185.
Yeah, 185 minus 177.6, right?
Or does it go the other way?
Yeah.
Is it 177 minus 185, or is it 185 minus 177?
No, you're right. It's 177.6 minus 185. Negative 7.4. And then.
Wait, why is it 177 minus 185? I thought it was 185.
It's the original population, or it's the original, yeah.
It's the observed value minus the
sample value.
Yeah.
Okay.
So the observed value was 177.6.
Right. And the previous value is 185.
So then now we take the standard deviation, which was 26.7, and divide that by the square root of 48. Right?
Right.
48 square root. Okay, and then we take the negative 7.4 and divide that by 3.8538, and we get a value of negative 1.920. And then we're just guessing the left and the right, not the middle, for 0.05. Is that what you guys got?
1.9.
3 decimal, 0.055.
0.05, yeah. 0.055.
So I think
All right, who goes first this time?
I'll go.
I can. Oh.
Let's see here. All right. Cool. We only missed one, and it was where'd it go? Oh, I was wrong on that question number 5. I think it must be the law of large numbers.
Oh, so we got number 5 wrong.
Yeah, change that to the law of large numbers and then have somebody.
All right, I'll go. That's it.
Cool.
Boom.
Boom.
Did that give you 100%, Rob?
Yes, it did.
Did you get your 100%, Kayla?
Yes, I did.
All righty, awesome.
All right. Then if there aren't any further questions, that leads us to good night.
Kayla, you got Tuesday, right? I'll get Thursday.
Yep, most definitely.
All right. I will
Have a good
see you
weekend,
all
guys.
Tuesday.
Okay, see ya.
All right, bye.
Bye.